Okay, welcome back to, I think that this is part 4 of 3.1 notes. My apologies for the long notes, but this is some heavy-duty stuff that we got to do here. Let's go ahead and continue what we were doing. What I want to do, remember, is calculate f prime of x, okay, which is a function that will generate the slope of the tangent line at any x value. Okay, and I get that by taking the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so let's uh, do what we need to do here, and let's plug things in and see what we do, see what we get. Okay, I'm going to move through this a little bit faster than I did the other one, just to try and save some time. But I want to calculate f of x plus h. Okay, so I've got 1 over 2 times the quantity x plus h, all right, plus 1. I'm going to go ahead and simplify that a little bit, and that's going to give me 1 over 2x plus 2h. Let me make sure that looks a little bit better. Okay, sorry, f of x plus h is 1 over 2x plus 2h plus 1. All right. I can't really simplify this any further, but this is what I'm going to use for f of x plus h, and this is f of x. So let's go ahead and let's plug that into here. Okay, let's find our derivative. So f prime of x is equal to the limit as h approaches 0 of f of x plus h. So I'm going to plug this in for f of x plus h. I'm going to put in 1 over 2x plus 2h plus 1, and then minus the function f of x. So minus 1 over 2x plus 1. Okay, and then remember, folks, this is all over h. And I know what you're thinking. You're like, why would he give us something like this? Why would he give us something just this absolutely awful to have us calculate the derivative by the limit definition? And you want to know why I'm giving you guys this problem? Because we can do it. All right? So buck up. Sorry, a little inappropriate. But let's go ahead and take a look at what we got here. I do need to kind of consider this negative sign up here. And make sure I keep that with my -1. That's my only worry about this. But what we want to do is we want to get this to a point where we have one fraction, okay? I've got incepted fractions. I've got fractions within fractions within fractions. Let's first of all just get one fraction in our numerator. So what I'm going to do is I'm going to multiply. I need to get a common denominator here. So I'm going to multiply this numerator and denominator by 2x plus 1, and this by 2x plus 1, and then I'm going to multiply this function by this denominator, and I'm going to make sure I keep my quantity here of 2x plus 2h plus 1, and then 2x plus 2h plus 1. All right, and so let me continue this problem here, and we get we need some room here. I've got the limit as h approaches 0. My numerator up here becomes 2x plus 1, and I'm going to do this. I'm going to do minus 1 times the quantity, 2x plus 2h plus 1, and then I'm going to divide that by my common denominator, which is the product of these two denominators, all right? So I've got 2x plus 2h plus 1 times 2x plus 1, all right? And then I'm going to divide this whole thing by h, okay? Now, I'm going to distribute my -1 up in my numerator here. Sorry, we're going to need a fair amount of room, so make sure you're writing small. So I get this. I get the limit as h approaches 0. Let me get my numerator all squared up. Let me distribute my negative here, and then let's see what happens. So I get this. I get 2x plus 1 minus 2x minus 2h minus 1. Huh. Oh, look at check that out, folks. A few things are going to go away here. All right. My attitude towards this will not go away, so get used to it. 2x plus 2h plus 1 times 2x plus 1, and then this is all over h. Okay, okay? So let's think about things we can do up here in my denominator, all right? I can get rid of the 2x minus 2x. That goes to 0. Okay, I have positive 1 and negative 1. Those also go to 0. So I'm just left with negative 2h. So let me rewrite this, and we get the limit as h approaches 0 of negative 2h divided by the product 2x plus 2h plus 1 times 2x plus 1. Okay, so now here's the step that we need to kind of be okay with. And this means that we're dividing by h. Okay, right here. All right, so I've got this top fraction here. I've got one fraction in my numerator, and we're just dividing that by h. Dividing by h is the same thing as multiplying by the reciprocal. Okay, so hopefully this is the step that doesn't screw you up. But I've got the limit as h approaches 0 of negative 2h over 2x plus 2h plus 1 times 2x plus 1. And then this is times 1 over h. Okay, these are equivalent statements. Dividing by h and multiplying by 1 over h means the same thing. Now look what I can do, folks. Now my h's divide out. Okay, so now I don't have this restriction in my denominator. I can now plug in 0. So let's rewrite our limit real quick. And so we get the limit as h approaches 0 of negative 2 all over 2x plus 2h plus 1 times 2x plus 1. Okay, now I'm going to go ahead and plug in 0, okay, because I can. I've divided out the h, so I'm going to go ahead and plug in 0 for h. So I get this. I get negative 2 divided by the quantity 2x plus 2 times 0. I plugged in 0 for h, plus 1 times 2x plus 1. All right, so now if I simplify this, all right, I'm going to end up getting negative 2 divided by 2 times 0 is just 0. So I get 2x plus 1 times 2x plus 1. Now I have the same thing here, so I get this. I end up getting negative 2 over 2x plus 1 squared, because I have 2 of them. Folks, this is my derivative, okay? This is f prime of x. This is a function that will generate the slope of the tangent line at any x value. So let me write that up top, all right, because we still got to go back and do the problem. All right, so f prime of x is equal to negative 2 over, what is that, 2x plus 1 squared, okay? Let me make sure that looks a little reasonable. Oh, God. All right, negative 2 over the quantity 2x plus 1 squared. All right, so that's my derivative, okay? So I want to, let's see what I got here. All right, I've got to find the equation of the tangent line at 0, 1. So I know that x equals 0. I know that y is equal to 1. I need to find the slope of my tangent line at this point, okay? So the slope of my tangent line is generated by finding f prime of 0. Okay, I'm trying to find this at x equals 0. So f prime of 0. So I'm going to go ahead and plug in 0 in for x here, and so I get negative 2 over 2 times 0 plus 1, quantity squared. So this gives me negative 2 over 2 times 0 is just 0 over 1 squared. 1 squared is just 1. So we just get negative 2. Okay, that's our slope. That's the slope of our tangent line, is negative 2. All right. So I have an x value, I have a y value, I have a slope of negative 2. I can now write an equation. Okay, so now I've got this. We've got y minus y sub 1 is equal to the slope m times x minus x sub 1. So I'll call this x1, y1. And so I get y minus 1 is equal to negative 2 times x minus 0. Okay, now let's put this into slope-intercept form so we can graph it. So I get y minus 1 is equal to negative 2x. Negative 2 times 0 is just 0. So I'm going to add 1 to both sides now. Add 1 to both sides. And so I get this equation of the tangent line. I get y equals negative 2x plus 1. All right, now I'm going to graph both this equation, the equation of my tangent line, in my original function, 1 over 2x plus 1, and we're going to see what happens at the point 0, 1. Okay? So, okay, hold on. What was it? 2x plus 1? Negative 2x plus 1? All right. So I've got my function in here. Okay, 1 over 2x plus 1. Here's the point 0, 1. All right? And I'm going to come here. I'm going to go to y equals, and I'm going to type in negative 2x plus 1. All right? And I'm going to graph that. And let's see what happens at 0, 1. Oh, boom! Look at that! That's so awesome! That is so freaking awesome! Look what we did! Is that good? Do we get that right? Okay, I'm gonna zoom in on that one. Zoom 1. Boom. Oh yeah. Look at this. Look at that 0, 1. Okay, it intersects there. Just check this out. And boom! Folks, this is what dreams are made of, okay? This is really cool. This is really fun. This is non-negotiable, okay? We are having fun. I got 2 more examples to do. And I hope you enjoy those as well.